Hi everyone, this is my brief introduction in the first slide of this PowerPoint presentation. This PPT containing the Karnataka University Dharwad, Nehru College, Hubli, BSc 5th semester mathematics subject presentation. The model of the presentation is numerical analysis. In the numerical analysis, the section can be taken as the solution of system of linear equations. In the numerical analysis, there are 4 units. First one is the system of nonlinear equations. Second one is the system of linear equations. Third one is the finite differences, and fourth one is the least square method. Here I am taken the second unit, solution of system of linear equations. To solve the system of linear equations, in general, I will write the n equations by using the n unknown terms x1, x2, x3 and up to xn. In the form of equation, it is written as a11 x1, a12 x2, a13 x3 plus and so on to be a1n xn is equal to d1. The second equation has the similar manner, a21 x1 plus a22 x2 plus a23 x3 plus and so on to be a2n xn is equal to d2. And the third line equation, a31 x1 plus a32 x2 plus a33 x3 plus and so on to be the nth term a3n xn is equal to d3. In this manner, to continue the equations, and finally we have to take the mth rows and n equation as a am1 x1 plus am2 x2 plus am3 x3 and so on to be amn xn is equal to dn. Here it is the coefficients of x1 in the equations a11, a21, a31, am1. Similarly, the coefficients of x2 are a12, a22, a32 and up to am2, and in the same manner the coefficient of x3 and coefficient of xn are there. We have to make it these equations in the form of a matrices. By matrices, above equations can be written as capital letter A using for the coefficient matrix, that is A is equal to the containing this matrix is the m rows and n columns coefficient of x1 to xn matrices a11. The particular meaning is there. If it is a11, that means the element A belongs to the first row, first column. a12 means the elements belongs to the first row and second column. Like that, it is the element a1n means first row and nth column. Similarly, whatever it is a21, second row, first column. Like that, if it is the m1, mth row, first column, mth row, second column, mth row, n column. So this is the m cross n matrix. For that, the unknown matrix is the x is equal to x1 to xn written in the column matrix, and the constant matrix, that is the RHS terms d1 to dn, has been written by means of a b. These are the matrices a, x, b. Multiplying a into x, we get a b means all the equations we have been again reformed. So by matrices, the system of linear equations can be written as ax equal to b. So these are the linear equations. In this topic, our work is to find out the values of these unknown equations. Here I written the m rows and n columns. In particularly, we are using the third order and fourth order. That means 3 unknown terms and 4 unknown terms equations. That can be seen by means of one method. So there are some methods are using for finding the solution of linear equations. Here it is the first method, Gauss elimination method. In this Gauss elimination method, I want to first find out the theoretical part, to take the 3 unknowns and find out the values of that unknown terms. To solve the linear equations, a1x plus b1y plus c1z is equal to t1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So there are the 3 equations and the 3 unknowns are there. So in the method we have to first find out the argument matrix. What is this argument matrix? Argument matrix is nothing but the matrix AB. That matrix AB is written in terms of a bracket using matrices. The A1, A2, A3, B1, B2, B3, C1, C2, C3. Observe these equations. The coefficients of x, y, z is written in the first 3 rows and 3 columns. The D1, D2, D3, that attachment of B has been written. This is the matrix AB. Suppose in the particular thing, what is the square matrix means? The square matrix is, these are the terms A1, B1, C1, A2, B2, C2, A3, B3, C3. This D1, D2, D3 is the supported column that forming the argument matrix AB. According to the Gauss elimination method, our work is to find out the values of a x, y, z. According to Gauss elimination method, convert this argument matrix into the upper diagonal matrix. That means below the lower diagonal elements should be 0. For that, make the terms, these terms A2, A3, B3 to be 0. How to make it the terms A2, B3, A2, A3, B3 to be 0? That to be by means of a elementary transformation. For that, the process, operate the first row to the second row and third row, operate R1 to R2 and R3, make the terms first A2 and A3 to be 0. With the help of this A1, first to make it the terms A2 and A3 to be 0. For that, what is the argument matrix AB becomes? Whenever I am operated the A1 to the first, second row and third row, this A2 becomes 0, A3 becomes 0. The remaining terms are distributed. That means B2 changes, C2 changes, D2 changes. Similarly, B3, C3, D3 changes. That changes can be written in the matrix AB. The AB becomes A1, B1, C1, D1. It remains same. A2 0, A3 0. B2 becomes a B2 dash, C2 becomes a C2 dash, D2 becomes a D2 dash. Similarly, the B3, C3, D3 changes to the B3 dash, C3 dash, D3 dash. Next, our work is, with the help of this B2 dash, make it this B3 dash to be 0. That means operate R2 to R3. That is the process. Operate R2 to R3 and make it the term B3 dash to be 0. So this AB becomes B3 dash 0 means remaining terms are distributed, changes. Therefore, C3 changes to C3 double dash, D3 changes to D3 double dash. The first row and second row remains same. So look at this square matrix. Here it is the diagonal elements A1, B2 dash, C3 dash. Below that, diagonal elements are 0. With the help of this matrix, again you have to be expand this matrix by means of equation. We get the values of x, y, z. From this, the third line C3 double dash z is equal to C3 double dash z is equal to D3 double dash. From this we get a value of a z. From the second row we have B2 dash y. We have the B2 dash y plus C2 dash z it is. C2 dash z is equal to D2 dash. And from the first line we get a A1x plus B1y plus C1z equal to D1. The z and y is to be substituted here. We get the value of a x. So this is the process of finding the values of x, y, z from the Gauss elimination method, which is the required solution. Next, to go for the Gauss-Jordan method of finding the solution to the linear equations. Again, to take the linear equations consisting the three unknowns by means of the equations A1x plus B1y plus C1z equal to D1, A2x plus B2y plus C2z equal to D2, A3x plus B3y plus C3z equal to D3. Now to look at the what is the Gauss-Jordan method says. According to the Gauss-Jordan method, what we have to be make. First, the argument matrix to be written. The argument matrix AB, that is equal to A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. According to Gauss-Jordan method, we have to be make it the upper diagonal elements B1, C1, C2, lower diagonal elements A2, B3 to be 0. According to Gauss-Jordan method, to convert this argument matrix into the diagonal matrix. Diagonal matrix means except the diagonal elements, all the elements should be 0. For that, make the terms A2, A3, B3 and B1, C1, C2 terms to be 0 by means of elementary transformation. Using R2, you may use the R1, nothing to be wrong. I am using R2. With the help of A2, I will make the A1 and A3 to be 0. That is, I said using R2 element B2, using R2 element B2, using A1 make it the A2, A3 to be 0, it is correct. But here I am taking the B2 and making B1, B3 to be 0. Using R2 element B2, using the second row element B2, make it R1 element B1, make it R1 element B1 and R3 element B3 to be 0. What happens? The R2 remains same and R1 and R3 has been changes. Then AB becomes A1 changes to A1 dash, the term A2 becomes 0, C1 changes to C1 dash and D1 to D1 dash, R2 remains same, and similarly the B3 has been B3 has been 0, therefore A3 and C3 D3 has been changes to be written as a dash. Next the process is using R1 the first row, using the R1 first row A1 dash, make it A2 and A3 dash to be 0. Using R1 element A1 dash, using R1 element A1 dash, make it the R2 element, make it the R2 element A2 and R3 element A3 dash, R3 element A3 dash to be 0. The first row remains same because I am operating first row to the second row and third row. These two elements are becomes 0 and B2 C2 D2 changes to B2 dash C2 dash D2 dash. Similarly the A3 dash becomes 0, C3 changes to C3 double dash, D3 dash changes to D3 double dash. Now with the help of this C3 double dash, make it the term C2 dash and C1 dash to be 0. Using R3 element C3 double dash, using R3 element C3 double dash, make it the R2 element C2 dash, R2 element C2 dash and R1 element C1 dash, and R1 element C1 dash be 0. Then the argument matrix AB becomes now that A1 dash remains same, 0 C1 dash becomes a 0, A1 dash changes to A1 double dash, these are 0 and D1 dash becomes a D1 double dash. Similarly with the help of this C3 double dash, it is 0, these two are changes, that changes has been written B2 double dash and D2 double dash. So this is the diagonal matrix. With the help of this diagonal matrix, we get a C3 double dash and D3 double dash by means of equation, and A1 double dash D1 double dash by means of equation, B2 double dash and D2 double dash by means of equation. From the above matrix, we get A1 double dash X is equal to D1 double dash, A1 double dash X is equal to, this is A1 double dash X is equal to D1 double dash, B2 double dash Y equal to D2 double dash, C1 double dash Z is equal to D1 D3 double dash. With the help of this, we get the solutions of the X, Y, Z. So this is the Gauss-Jordan method for finding the values of X, Y, Z. Next to go for the Gauss-Seidel iteration method. In the Gauss-Seidel iteration method, again to take the three unknown equations to solve the following equations similar manner. A1x plus B1y plus C1z equal to D1, A2x plus B2y plus C2z equal to D2, A3x plus B3y plus C3z equal to D3. So one must remember this Gauss-Seidel method, it is maximum used whenever the diagonal elements weightage is more than the remaining elements. These are diagonally dominated equations. Diagonal means A1x, B2y, C3z, A1, B2, C3 values more than their remaining coefficients. Okay, that will be clearly understand whenever you are solving on the examples. Method. Again to write the argument matrix. No need to write the argument matrix. To rewrite these equations, to write the above equations. From this equation, first equation to find the value of a x. From this second equation to find out the value of a y. From the third equation to find out the value of a z. To write the equations, x is equal to, that a1x is equal to first. From the first equation, we have keep the a1x as it is, transfer these b1y, c1z to the RHS side, and thereafter a1. So we get x equal to 1 divided by a1 into bracket d1 minus b1y minus c1z. From the second equation to find out the y, that is y is equal to 1 divided by b2 into bracket d2 minus a2x minus c2z to be written here, that is y. From the third equation, to find out the value of a z, that z becomes 1 upon C3 into bracket D3 minus A3x minus B3y. Call these equations as to be 1, 2, 3. From the given equations, you rewritten the values of x, y, z in this way. From the first equation, finding x. From the second equation, finding y. From the third equation, finding z. With the help of these equations, to find out the values of x, y, z. For the first approximate root, to follow the process, first set of approximate root or first set of iterative roots are, put y equal to 0 in the first equation, put y equal to 0 and z equal to 0. If y and z are 0, then what happens? This x is a 1 divided by a1 into d1, because y and z to be 0, that to be written as x1. X is equal to d1 divided by a1, that to be written as a x1. That means x is x1. Now in the second equation, put x equal to x1 and z equal to 0. Put x equal to x1 and z equal to 0, then the y becomes 1 divided by b2 into bracket d2 minus a2 x1. Call this expression as to be y1, or this is the y1 root. Next, put x equal to x1 now and y equal to y1 in the equation number 3. We get the z is equal to 1 divided by c3 into bracket d3 minus a3 x1 minus b3 y1. Call this is a z1. So the x1, y1, z1. These are the first approximate root of the given simultaneous linear equations, or first iterative roots. Now x is x1, y is y1, z is z1. Repeating this process again to consider the equation 1, 2, 3 for the second set of approximate roots or second iterative roots. Put x equal to x1 now. Put x equal to x1, so it is y equal to y1 I written, make it x equal to x1 and z equal to z1 in the equation 1. What you get? That x2 equal to 1 upon a1 into bracket d1 minus b1 y1 minus c1 z1. Y equal to y1, it is correct one. Y equal to y1 and z equal to z1. x2 is equal to 1 divided by a1 into bracket d1 minus b1 y1 minus c1 z1. That x can be written as a x2 here for the second iteration. And next, put x equal to x2, z equal to z1 in equation 2, we get the y2, that is 1 divided by b2 into bracket d2 minus a2 x2 minus c2 z1. Now put x equal to x2 and y equal to y2 in the equation number 3, we get that z2 equal to 1 divided by c3 into bracket d3 minus a3 x2 minus b3 y3. So these are the x2, y2, z2 are the second iterative roots. This process will be continued till to get the values of x, y, z desired accuracy. So this is the Gauss-Seidel iteration method. So in this video you are taken the three methods. First one is the Gauss elimination method. Second one is the Gauss-Seidel iteration method. Gauss-Seidel second one is the Gauss-Jordan method, and next one is the Gauss-Seidel iteration method. So try to watch out the videos and again and practice the theoretical part of solution of system of linear equations. In the next class, to solve some examples on these methods.